Let us then look at how to do this. And we're going to use exactly the same strategy that we used before. We're going to start with the propositional case, right? Because that's the simpler case. If we don't know how to do this, induction by inverting deduction for propositional rules, we don't know how to do it for the first order case. It's too hard, right? What we're going to do is we're first going to solve the propositional case, and then we're going to generalize it to the case where I have predicates and arguments and all that good stuff, just like we did before. Okay? So let's start with the propositional case, and the place to start, of course, is with what is deduction exactly. Now, deduction can be done in many different ways, but usually it's done using what's called the resolution rule. How many people here have heard of this stuff, resolution? Just so I can have, I can calibrate. If you've heard of this, raise your hand. Okay, very good. Nobody has heard of it. That is the second best case. The best case is everybody has heard of it and we just, breeze through. The second best case is when nobody has, because that way nobody's bored. Right? So hopefully nobody will be bored here. Or at least if you're bored, then it's because I'm a bad teacher, which, could be the case. So what is resolution? Resolution is how most theorem provers work. When you hear about, computers proving new theorems automatically with our help from people, or a proof being checked automatically, or, there's lots of things that use theorem proving. Like, for example, software and hardware verification are often done using theorem proving. You prove that circuit does what you want. What are those guys using when they do that? They're probably using resolution. I mean, there's many things that you can use, but resolution is probably the single most widely used. And here's resolution for you in one very simple little table. Right? This table, you can read it like you read an addition. 3 plus 4 equals 7. Right? So what I have here is that from this and this, I can deduce this. So what are these things? Here what I have is just the simplest case, right? So first of all, each of these things is what is called a clause. A clause is just a disjunction of literals. And the literal is just a statement or its negation. Like P, for example, could be the statement, it's sunny today. And L could be the statement, we're in Seattle. Okay? You could also have the negation of that, we're not in Seattle. So you could have something like not P or not L. Okay? And a clause is just a disjunction of those things. Clauses are useful to us because whatever you have in first order logic can always be converted to C and F. Clausal normal form or conjunctive normal form. Okay? So let's assume that everything that we have is in the form of clauses, right? Makes life much simpler, more uniform. And here's what the resolution rule says. It says that if I have, this is not the general resolution rule, but it's a simple case for us to get a handle on it. It says that if I have in my knowledge base the clause P or L, remember P and L are just Boolean variables, and I also have the clause not L or R, I can infer the clause P or R. Right, so these are what I had before, and this is what I have after I apply resolution. So another way of saying this is that P or R is a deductive consequence of P or L and not L or R. If I know those two things, it follows with complete certainty that P or R. Now, why is that the case? Can anybody tell me? What is the basic insight behind resolution? Let me give you a hint. In logic, right, the basic thing that logic commits to is that every statement is either true or false, right? You can't be both, and there's no other thing that you could be, right? So every one of these literals here is either true or false, okay? So in particular, here's the hint. Let us focus on this literal L, right? This is an interesting literal because it's actually the one that appears in both of the clauses, right? And we know that, that L is either true or false, right? So what can we tell about P if L is false?
It's true.
Must be true, right? One of them is true, L is false, so P must be true. What can I tell about R if L is true?
It's true.
Then it must be true, right? Because not L is false, therefore R must be true. Okay? So to recap, I know that if L is false, P must be true. On the other hand, if L is true, then R must be true, right? And what do we know about L by logic is that it's either true or false, right? Therefore, what do I know about P and R?
One of them is true.
One of them must be true, right? Because either L is true or L is false. In the first case, P is true, and in the second case, R is true. Right? This is what the resolution rule is all about. Very simple, but very powerful. Any inference that you can do in logic, you can do using just resolution and nothing else. Question?
Yes, you can write this as like not L implies P, right?
Yeah, absolutely. This is a very good point. So, often when you're looking at these clauses and trying to figure out exactly what they mean, it's good to remember that, the clause not A or B is another way of writing A implies B. So in my knowledge base, usually what I have is things of the form A implies B, right? If you have the symptom, then you have something, right? But when I convert that to clausal form, it becomes not A or B. Because remember, an implication is true if the consequent is true or if the antecedent is false, right? If the precondition is false, then the implication is true no matter whether you have. If you don't have this, the symptoms, then whether or not you have the disease, the rule is valid. The rule is true. Okay. So you can look at this, for example, and say, oh, what I'm saying here when I say not L or R is L implies R, and so on. Okay. And in fact, we're going to see an example of this in a little bit, where very much, the implication form is very intuitive. But to do resolution, we need to convert things into clause form. Okay. So did everybody get what the resolution rule is? This is absolutely key to what's going to follow. Okay. So, what is the general rule? The general rule goes like this. So how do I apply resolution, right? I have a big knowledge base of stuff that I know. And now I have a question, I have a query, right? Is it the case that Socrates is mortal? Is it the case that Anna is the mother of Baal? I want to know. Can you figure that out for me? And I just claim that you can figure that out using resolution if you can figure that out at all, right? So how would you do that? Well, you have to find a sequence of applications of the resolution rule that will take you from what you know to the question that you're asking, either yes or no. Okay? So how do we do that? Well, here's the idea. Notice that the key thing that the resolution rule depends on is that I have a literal in one clause that appears negated in the other. Right? This is the thing that's going to bind them together into a result. Right? The result, by the way, is called a resolvent. This last clause here is the resolvent. So here's the recipe. Given two clauses, C1 and C2, I find the literal in one clause that appears negated in the other. Right? Look through your clauses and try to find, something that appears negated in one but not the other. And these two are a candidate for resolution. Okay? And then how do I form the resolvent, right? If I have found that, what is the new clause that I can now form? Right? Well, look at what happened in this example, right? The two L's disappeared, right? They kind of canceled each other out, colloquially putting it. Okay? And then what's left is the rest. Right, sorry, the P became this P, and the R became this R. Okay? So what is the recipe here? Is that the negated one disappears, and all the other ones get glommed together into one new clause. Okay? That's what we do. Here's the same thing, just written as a formula. The resolvent C is going to be C1 minus the singleton set formed by L, union C2 minus the single set formed by not L. Okay? So we're thinking of the knowledge base as a set of clauses. Okay? Everybody see this? Why did we take the trouble to write this down formally? Because, hey, we're trying to invert this. Now that we've written it down like this, we can figure out how to do the inverse, right? What is the inverse of this? Right? So deduction was going from C1 and C2 to C, right? What is induction going to be? Right, in deduction we went from the two clauses to the resolvent. What is the inverse of this?
Going from C and C1 to C2?
Exactly. Now I have the resolvent and I have one of the clauses. I want to figure out what the other one is. Right? Remember, I know that Socrates is mortal, and I know that Socrates is human. What I want to figure out is the other mystic thing that combined with Socrates is human would produce Socrates is mortal. Right? So to do this diagrammatically, actually let me jump to the next page. Well, actually here it is diagrammatically. Right? Well, let's just do this actual example. Right? And we're going to use this as a running example. The font is a little small, unfortunately. Hopefully you can read this. If you can't, let me read it to you, right? So let's look first at a very simple example of deduction by resolution and then see how we invert it, right? So here are the two clauses that I start with. C1 is pass exam or not no material. These examples are carefully designed to appeal to the student in you. Right? We are very proud of this, deep savvy. This one says no material or not study. So let me ask you first, what do these clauses mean in English? Remember, going back to this notion that a clause is really just another way of saying an implication. What am I saying here?
If you know the material, you'll pass the exam. If you study, you'll know the material.
Yeah, right? Does anyone disagree with this? Very good, right? Very natural things to say, right? And what is it that you could, so don't think about resolution for just a second, just use your common sense. What can you infer from this? Right, is there another rule that you can infer from these two rules, a very important rule in your life as students? Right? You know that if you study, you will know the material, right? Or sorry, it goes this way. Oops. Right? If you study, you will know the material. And if you know the material, you will pass the exam. Therefore, what can you say? If you study, you will pass the exam. Right? Aren't you learning amazing new things in this class? Yeah. So here it is. Well, if you study, you will pass the exam. Written in clausal form is pass the exam or not study. Okay? So hey, resolution and common sense agree. Okay? So this is our little example of deduction. Everybody got this? Okay, very good. But now what we want to do is induction. We want to do the inverse of this. What is the inverse of this? Well, deduction, right, was going from this and this to this. Right? Induction is the inverse. Right? In induction, I have the result. Right? And I have one of my two clauses. I want to figure out what's missing. I want to figure out the second clause, right? That's the goal here. So, over to you. How do we do that? Right? Let's suppose for just a moment that I hadn't seen this yet, right? How do I figure out what needs to be there? This is really, once you got this, everything else kind of follows, right? So let's look at these two, right? This clause was pass exam or not no material, right? And this clause was pass exam or not study. So, what does this clause have to be? What has to be in it?
The not pass exams.
The not pass exam. Why is that? Very good. Why is that?
From the rule before, you know that the other two to combine to make the resolvent need to not have, they take away pass exam.
Right.
On the prior slide.
Right, absolutely. So notice the following, right? Pass exam, right? No, sorry, what did you say? You said this rule has to contain what?
It has to I said it the reverse, but not. They need to contain not pass exam, the one that we're looking for on the right.
Yeah.
It doesn't need to contain no material because you know that the clause that's in both of them, the one negated, is the one that you remove, and you know that it's not in the final one, so it must be in the other one.
Exactly. I actually jumped the gun and I thought that he was saying what you're saying. Right? So very good. Notice the following important thing. No material has disappeared. Right? No material is in C1, but it's not in C. Right? So how do we make a literal disappear? There's only one way. Right? It's got to be negated in the other clause. Because that's the only way a literal disappears. Right? Is when it disappears in one clause and in the other clause negated. Right? So rule number one is the stuff that was in this clause but not this one has to appear negated in the other one. Otherwise, this doesn't work, right? The resolution wouldn't do the trick, right? Everybody agree with that? Okay, point one. Point two. Point 2 is actually the easier one in some ways, right? What is the other thing that has to happen? What else needs to be in this clause?
Not study.
Not study. Why? Hey, it just came out of nowhere, right? Not study was not in C1, so it has to come from C2, right? So there we have it. I now reveal the truth. This is like scratching those things with a coin to see if you won the lotto, right? This is high tech at its best, right? So here's our clause: no material, right? The negation of not no material, right, is here. So this is the literal that is actually going to allow the resolution to go through, right? It appears not negated in C2 and negated in C1. Or not study. This not study goes from this clause to this clause. Okay? So the general rule is, let us generalize from this, right? I have one of the clauses and I have the resolvent. The other clause needs to contain all the literals that appear in the resolvent but not in the first clause, right? They have to come from there. It also needs to contain the negation of what disappeared from the clause to the second, right? Or to the resolvent. What happens if more than one literal that was in the first clause is not in the resolvent? The answer is very simple. Nothing happens. That one could not have been obtained by resolution from the first one. At least not in one step. Okay? With multiple steps, maybe. Okay. All right. So any questions about this example? This example really encapsulates the whole idea here. So, here's our general and more formal statement. So here's my recipe for doing inverted resolution in the propositional case. Given my initial clauses C1 and C, where C is the resolvent, right? Remember, C is the thing that I'm trying to come up with the rules to be able to infer. Find the literal that occurs in the first clause, C1, but not in the resolvent, right? Look for a literal that has disappeared, not no material in our case, okay? And now, supposing I find it, right, I can form the second clause in the following way. The second clause is going to be C, the resolvent, minus, right, C1 minus that literal, right, union, not the literal, right? So let us parse this, right? This was a big mouthful, so let's see what happens here. C2 is going to contain everything that C contains that couldn't have come from C1, right? This is the not study literal, okay, in our example, right? So everything that is in C that wasn't in C1, right, has to have come from C2. So we need to put those things in there. Of course, excluding the L, because that one's going to, actually disappear, and for a different reason, right? And in addition, of course, C2 has to contain the negation of L to make sure that it cancels with L and the resolution goes through and L no longer appears in the resolvent. Okay? Everybody agree? So, here in one nice little formula is a very interesting idea for doing machine learning, for doing induction by inverting deduction, in particular by inverting resolution, which is the most widely used approach to deduction. Okay. Any questions? Very good. But of course, this was the